everyone. You're watching the 28th video in the series Mathematical Methods for Economics. In this video, we will take up the concept of elasticity. This is part of our segment on the economic applications of derivatives. And elasticity is the concept that we'll take up today. It is a concept that figures prominently in many areas of economic analysis. It is a concept that economists often talk about and often bring into their discussions. This particular video is going to be organized as follows. We will start by first introducing the notion of elasticity as also the general definition of elasticity. We will then go on to motivate this discussion using the price elasticity of demand, which is probably a concept that you might already be familiar with. Even if you're not, that's absolutely all right. And then depending on the availability of time, we will see how we can use the general definition of elasticity to calculate specific elasticities in economics. Also, an additional aspect that you can pay attention to while we go through this video, while we go through the discussion, is the distinction between an absolute change, a relative change, and a percentage change. So, one, an absolute change, second is a relative or a proportional change, and the third one is a percentage change. But before anything else, let us first understand what we mean by the term elasticity. When we talk of elasticity, the key word here is responsiveness or sensitivity. So here we want to understand the degree of responsiveness of one variable with respect to a change in another, or we want to look at the degree of sensitivity of one variable with respect to another variable. Now, when we carry out economic analysis, let me just give you some perspective here. We don't just talk about, let's say, if I give you an example, suppose if I say the quantity demanded of a particular commodity goes down when its price increases, all other things remaining the same. Or if I say that when income increases, when income of an individual increases, the demand also increases. And in such situations, it's not just enough to talk about the direction of the change. It's not just enough to talk about the direction in which, let's say, quantity demanded increases or decreases, or demand increases or decreases. But we would also be interested in the magnitude of the change. So elasticity then gives us a measure of how much buyers and sellers, by how much buyers and sellers respond to a change in market conditions. So if we have, let's say, an event or a policy that affects some aspect of the market, what we are interested here is not just the direction of the change, but also the magnitude of the effect. And that is exactly what elasticity helps us get to. Now, the way this lecture is going to be organized, because this is a lecture on mathematics and we are doing elasticity here as an economic application of derivatives, the way we're going to approach the topic of elasticity is going to be a little different from what you ordinarily do in other courses. So, what I'm going to do here is I'm going to first bring in a generic definition of elasticity, a general definition of elasticity, and once we are set with that, we can just use that definition to calculate any kind of elasticity. There are various kinds of elasticities that we look at in economics, but once this definition is set up, we can use this definition to calculate any specific elasticity that we would like to calculate. So to see how this definition is is set up. Let's suppose we have a variable y which is a function of x, and here we are taking y as a differentiable function of x for convenience. In particular, we would like our measure of elasticity to be independent of the size of the change in x. So in that sense, it's easy to have a definition. It's easy to work with a definition where the function f is differentiable at x. Now, if f of x is not equal to 0, we then define the following, which is the elasticity of f with respect to x, and that is given by f prime of x times x divided by f of x. So, we use a notation here with EL of the elasticity, the first two letters of elasticity, the elasticity of f of x, and the variable with respect to which we calculate the elasticity appears as a subscript in the middle. So, we have it here between EL and f of x, the variable with respect to which we calculate the elasticity. So, this is a notation, elasticity of f of x with respect to x, that is a derivative of the function with respect to x times x divided by f of x. Alternatively, books also use a notation elasticity of y with respect to x, because ultimately we have y equal to f of x. So, elasticity of y with respect to x, or epsilon sub yx. There are various kinds of notations that you find in different books. I personally like to work with the notation elasticity of y with respect to x, which is then written as, instead of f prime of x, we will now just write dy by dx, and this is a notation which is easy to keep track of. So, when I take the elasticity of y with respect to x, I first take the derivative dy by dx, the derivative of y with respect to x, and then multiply by the ratio of the variables in the reverse order. So, I have x by y with which I multiply dy by dx. So, this is the elasticity of y with respect to x, and this is a general definition of elasticity. Now, let us give it some perspective. Let us go a little deeper into this definition and motivate it with the help of an example which for which I am going to use the concept of the price elasticity of demand. So, what exactly are we doing here? When we are talking about elasticity, when we are bringing this concept of elasticity, we want to understand how the variable y responds to a change in x, right? Now, to just give it some perspective and bring in things from the point of view of what we do in economics. So, let us just replace y, which is a dependent variable, with the demand, the demand for a particular commodity, the quantity demanded for a particular commodity, which I am representing by Q. And the x variable, which I have in the original definition, I am just representing that by the price. So, I have Q, my demand function, where the quantity demanded is a function of price. So, Q is a function d of P. Now, what I am going to do is, let us ask ourselves, how can we understand how the demand for a particular commodity responds to a change in its price. So, let us approach things in this way, and let us just get down to first principles, and from first principles arrive at this definition, which is a general definition of elasticity. So, this just helps us get some intuition behind this definition, and as to we get some sense of how this definition comes into being. So, let us look at things in this way, where Q is a function d of P, and one way to approach this issue of responsiveness, because we want to understand the degree of responsiveness of one variable, in this case we want to understand how quantity demanded of a particular commodity responds to a change in the price of that commodity. So, one way in which we can pose this question of responsiveness is to ask, by how many units does the quantity demanded of a commodity, and here I'm going back to first principles, I'm just going back to something very basic. So let's just ask a very basic question: by how many units does the quantity demanded of a commodity change when its price increases by 1 rupee? Now, mathematically, this question would be answered through the expression delta Q, change in Q divided by change in P, because this then tells us the absolute change in Q, the number of units by which quantity demanded of a commodity will change for a unit change in P. So that is what delta Q by delta P is reflecting. Now, this is one of our proposals. Let's suppose we propose this as a measure of responsiveness. However, there are two problems here. There are two issues that come up here. One is that the value that you get here for delta Q by delta P is not going to be independent of the units of measurement, because this value will change whenever there is a change in the units of measurement of either Q or P. That is one of the issues here, that you are not going to get something which is independent of the units of measurement. The second issue that arises in posing the question of responsiveness in this way is illustrated here on this slide. Let us suppose we have two commodities. Let us suppose we have, let's say, onions, and we have television. So these are two commodities that we are taking into account. And the price for onions, let's say, increases from 50 rupees this week to 100 rupees. Okay? And at the same time, the price of a television increases from, let's say, 20,000 rupees to 20,050 rupees. Now, what do you notice here? For both the commodities, whether it's onions or a television, for both the commodities, the price has gone up in an absolute sense by rupees 50. So the absolute change is the same. But there is a difference here. Clearly, a 50 rupees increase per kilo of onions, this is per kilo of onions, is quite considerable. Whereas if the same increase in price, which is 50 rupees, happens for a television where initially the price is 20,000 and then becomes 20,050, that's not going to matter much. That is an insignificant change. In fact, for onions, you can see that the price has doubled. And in fact, this is this can lead to a crisis. Literally, you have had governments fall because of increases in prices, such steep increases in prices of onions. So, here, the point that we are trying to make is that looking at an absolute change may not reflect the true picture depending on the commodity that we are taking into account. So, the solution here that we are proposing is that we use relative changes. Okay? And if we are looking at relative changes, let us now see how we can arrive at a measure of price elasticity of demand, which we're going to, which is what we're going to call this particular responsiveness. We're going to see how this can be expressed, how we can arrive at a measure of elasticity, which is based on relative changes. So our demand function here was Q equal to D of P. Now, let us suppose price changes from P to P plus delta P. So, the change in price is delta P. In our case, that's for our example, it was 50 rupees for onions or television. If this is the case, if the price increases from P to P plus delta P, or let's make it even more general, the price changes from P to P plus delta P, then the relative or the proportional change in Q is given by delta Q divided by Q. So, this is a relative change, this represents a relative change in Q. So, this helps us get a base. We are looking at the absolute change, but we are also dividing the absolute change in Q with the initial value. This then gives us a relative or the proportional change in Q. And this delta Q by Q, if we write things in terms of the demand function, the change in the quantity demanded would be D of P plus delta P minus D of P, that will be delta Q, and then we divide by the initial value, which is D of P at the particular price P. Similarly, the relative or the proportional change in price is given by delta P divided by P. And now the measure of elasticity that we get is given by the relative change in quantity demanded. So, instead of looking at by how many units does quantity demanded change when the price of that commodity increases or changes by 1 rupee, we are now looking at the relative change in quantity demanded divided by the relative change in price as the measure of elasticity. This mathematically would then be given by delta Q by Q divided by delta P by P, and this is known as the average elasticity of demand in the interval P comma P plus delta P. I hope that makes sense, and this then our elasticity measure is given by the relative change in quantity demanded divided by the relative change in price. So, we moved now from absolute changes to relative changes. Alternatively, we can make a slight adjustment to this relative change ratio, and we can we can rewrite elasticity as a percentage change in quantity demanded divided by the percentage change in price. So, that would simply mean that I multiply both the numerator and the denominator in the expression on top by 100, and once I multiply that the relative changes by 100, I get the percentage change. So, the elasticity here is represented as the ratio of the percentage change in quantity demanded and the percentage change in price. So, the question that we are now posing to examine the degree of responsiveness is by what percentage does the quantity demanded of a commodity change when its price increases by 1% or when its price changes by 1%, and this we are going to call the price elasticity of demand. So, the price elasticity of demand tells us by what percentage the quantity demanded of a commodity changes when its price changes by 1%. And this is the price elasticity of demand at a given price, and the advantage of taking the percentage change or the relative change, the ratio of the percentage changes or the relative changes, is that this number that we get, this is a pure number. The elasticity measure that we get here is a pure number, and it is free of the units of measurement. Now, let us suppose, let's give some examples to understand what we've just set up. We have just set up elasticity as a percentage change, here we're talking of the price elasticity of demand. So, we are talking of the price elasticity of demand as the percentage change in quantity demanded divided by the percentage change in price. And let us suppose that the price elasticity of candy, which is let us say calculated through this formula. Let us suppose that price elasticity, the own price elasticity of candy in a certain country is found to be minus 0.4. What you should get used to here is how you should interpret such statements. When you read such statements, how you should interpret these. So, because your elasticity of demand, price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price, this tells us we can interpret the statement in the following way, that an increase of 1% in the price of candy would lead to a decrease of 0.4% in the quantity of candy demanded, provided all other factors that influence its demand remain constant. This is a standard ceteris paribus assumption in economics. Alternatively, we could also say an increase of let us say 10% in the price of candy would lead to a decrease of 4% in the, because if it's if a 1% increase in the price of candy leads to a decrease of 0.4% in the quantity of candy demanded, then that is to say that if there's an increase of 10% in the price of candy, that would lead to a decrease of 4% in the quantity of candy demanded, ceteris paribus. So, this is how we read such statements. Similarly, you might find a statement like this, which is something I've borrowed from the Man-Q book for microeconomics. This says that the demand for mystery novels is likely to be more elastic than the demand for required textbooks. So here we have that required textbooks would have a demand which is typically inelastic, because you won't be able to find any substitutes for textbooks that are required, whereas you might be able to find other alternatives for mystery novels. So you would expect the demand for mystery novels to be more elastic. In fact, going back to the example on candy, if you look at the number here, the elasticity of demand with respect to price is minus 0.4, and also because the demand curve is downward sloped, we have a price elasticity of demand here which is going to be negative. But for purposes of comparison, we do the comparisons by looking at the absolute value, because it's easier to handle things with the absolute value. So what we are saying here is that if the price elasticity of candy is minus 0.4, this is a case where we're going to say that the demand elasticity is inelastic. The demand for candy is inelastic, and this would be the case where the percentage change in quantity demanded is going to be less than the percentage change in price. Okay, then we have another statement here. So there's a study that found that the demand for full cream milk is elastic. So here the price elasticity of demand was found to be minus 1.42, and for skimmed milk the demand is inelastic, and the elasticity of demand with respect to price for skimmed milk was found to be 0.53. And here again we can explain this difference in the elasticities for the two commodities in terms of the availability of substitutes. So perhaps for skimmed milk you will not be able to find alternatives. It's not easy to find alternatives. So this is going to be a product which will have an inelastic demand. Now the question is, we have so far expressed the price elasticity of demand as the ratio of the relative change in quantity demanded and the relative change in price. So that's delta Q by Q divided by delta P by P. We can now ask, can we arrive at a measure of price elasticity of demand which is independent of the change in the size, which is independent of the size in the change in price? Which is to say, can we ask what happens to the ratio for the relative change in quantity demanded to the relative change in price as delta P tends to 0. We want it to be independent of the size of the change in price, the size of delta P. So we want delta P to go to 0. So in this case, we want to understand what is delta Q, because I can write this ratio of the relative change as delta Q by delta P times P by Q. So I can look at what happens to this ratio in the limit as delta P tends to 0. This would then mean I'm looking at the expression, the limit as delta P tends to 0 of d of P plus delta P, because the change in Q will be given by d of P plus delta P minus d of P divided by delta P times P by Q. So this is the expression that we will have, and as you all know from your chapter on differentiation, that the limit as delta P tends to 0 of d of P plus delta P minus d of P divided by delta P is nothing but the derivative of the demand function with respect to price, and this is then multiplied by P by Q. And because the derivative of the demand function with respect to price is nothing but dq by dp, because q is a function d of p, so d prime of p is dq by dp. So our elasticity, the price elasticity of demand, can be written as dq by dp times p by q. So the elasticity of demand with respect to p, as I said, can be written as d prime of p times p by q, or dq by dp, the derivative of q with respect to p, times p by q. Now what we can do here is, we started from the absolute change, went on to the ratio of the relative changes, and then we said we want a measure which is independent of the size of delta P. So this is what we've arrived at. And now let's just compare this. If you look at the definition that I started out with in the beginning of the video, we said that the elasticity of a function f of x with respect to x is given by f prime of x times x, the variable with respect to which you're calculating elasticity, divided by f of x. And you can see here that there is a clear correspondence between the definition that we've come up with for the price elasticity of demand, that's d prime of p, which is the equivalent of our f prime of x, and that is then multiplied by p by q, so which p was our independent variable. This is the variable with respect to which we are calculating the elasticity. So that is coming in the numerator, that is divided then by q. So q here is the equivalent of f of x. So there is an exact comparison here that we get with the generic definition that we set up in the beginning of the video. Now let us go through an example to understand how the price elasticity of demand is calculated. So here we have the quantity demanded for a particular commodity, which is given by d of p equal to 10 times p to the power minus 0.75. The question asks you to compute the elasticity of demand with respect to price, and we'll just use our standard definition. So the elasticity of demand with respect to price is d prime of p times p divided by d of p. Now d prime of p, as you can see here, when I differentiate this function, I get 10 times minus 0.75 times p to the power minus 1.75. So that's what you have here, times p divided by d of p. So d of p is nothing but 10 times p to the power minus 0.75. And you can see here that all the p's here will get cancelled, because in the numerator I have p to the power minus 1.75 times p. So that's going to give me a p to the power minus 0.75. That will then cancel out the p to the power minus 0.75 in the denominator. So we can do away with the price, the expressions with the p variable in them. And then even the 10 here will cancel out the 10 in the denominator. So what we are left with here is minus 0.75. Further, the question asks you to find the percentage change in quantity demanded when the price increases by 1% from p equal to 2. Now this is actually, this way of calculating things is a good, it provides a good approximation to elasticity without having to take derivatives, and you can see here in the end that you'll get the result which is consistent with what we calculated in part A. So, because in part A we are using the derivative where we are getting delta P to go to 0. So, here because we have price increasing by 1%, we are going to do the complete calculation. So, because the original price is P, the quantity demanded at the price P equal to 2, that is the original price, that is going to be given by 10 times, I am just substituting P equal to 2 in the demand function. So, that is going to give me 10 times 2 to the power minus 0.75, which if you calculate is approximately equal to 5.946. The new price, because price has increased by 1% from P equal to 2, the new price is going to be 2.02. So, D of 2.02 if we calculate, that comes out to be 10 times 2.02 to the power minus 0.75, and that you can calculate, when you calculate you will see that is approximately equal to 5.902. So, when we calculate the percentage change is equal to in discrete changes, that's a new value minus the old value divided by the old value. So, or the final value minus initial value divided by the initial value. So, the final value would be D of 2.02, which is 5.902, minus D of 2, which is 5.946, divided by D of 2 times 100, and that then gives us minus 0.044 in the numerator divided by 5.946 into 100, and that is approximately minus 0.74, which actually, if you notice, is consistent with the price elasticity of demand that you had calculated in part A, which was minus 0.75. So, that is all we have for this part of the video. Thank you.